This is going to be the fun, speedy vector talk in the land of rest raster talks. So, all right, yeah, I got the remote right. All right, so howdy, folks. My name is Gregory Power, and I work for the town of Cary. I originally got my degree from here way back in 2017 in fisheries and wildlife, not a lick of computer science and not a lick of programming. I knew more about identifying birds than working with Python. So that I learned all the programming stuff afterwards and how I got roped into open source geospatial and the joys of grass. So, alrighty. So, most of you probably will do some spatial analysis in your lifetime as geospatial nerds. And one of the things that I do at the town of Cary is I maintain our town's open data portal. So, what do you do when you have spatial analysis questions? Is that you're gonna, for us, like I'm gonna download some parcel data. I want to know either like my council districts. I'm going to download some point layer, and then I'm going to see usually for questions that I get asked or like, for my council folks, they want to know how many crashes happen in their district, what crimes happen in their district. So I go to download those layers from our ArcGIS online portal. And so usually what that happens is I download my stuff, try to do my spatial join, and I don't get a layer because of invalid geometries. So you can see I'm colorblind and I can see big red error text. So that's kind of my first reasons of like, there's got to be a better solution other than saying, oh, I can just draw points wherever. There has to be some rules, some way of preventing this issue downstream. And that's how I got roped into grass. So cool differences between grass is they've got a really cool way of dealing with topology and how they represent geometries. So kind of doing a comparison here between your regular OGC, simple features, a bunch of fun technical documents about specs, is that you do have your points, lines, polygons. I'm going to ignore multi-polygons, multi-points, and collections and all that fun stuff. But grass, you have more options for how to define relationships between your spatial data. So you have more rules, and that means you have more opportunities to check before you export a data set. So there's two levels for grass's topology. Level one is your spaghetti model. Don't blame me, that's in the documentation. Personally, I feel like it's a broken spaghetti because it's a crime. But you have level two, which is your topologically correct and super cool forms of data, which you can create within grass. And even outside of grass, but using grass. So here's a long list of options for being able to clean your topological data. So other options for how I deal with it is all right, so easy way is like vimport is my fun way of like, all right, if I only want to ever deal with valid geometries, I'm going to use vimport and just, any invalid geometries I'm going to drop. So other options is if I want to like use grass as a way to house my data that I download and be able to work with it, I'm going to use my V in OGR, and then I'm going to use a process called vbuild to be able to look at my features that are causing me problems. So, and then I can use the joys of vclean, which automates a whole set of topological checks using the super fun topological model that grass supports, even though it's not technically OGC, but it goes beyond OGC. So anything you can get to work in grass will work outside of grass, and your citizens and your folks will thank you. So, and your future self. So, a couple options for getting data out once you are good and clean is vclean OGR. So anything that you can use with OGR or GDAL's new fancy CLI interface, Grass uses to be able to export any kind of file or anything that you need. And you can also use vout OGR. So yeah, TLDR. Oh, second. Okay, my bad. Oh yeah, it is too long of a presentation. I'm sorry. But yeah, so the TLDR is that Grass is a pretty solid pipeline for being able to clean data before you share it with the public. and it's pretty awesome. So yeah.